Hey guys, welcome back to Play on Wheels. In today's video, I'm going to show you how we built a super cheap electronic fuel injection system for the Flathead V8 in our 1950 Ford two-door. Before we dive into the new EFI system, I want to show you guys the parts that came off the car so you can see where we're going from and what we're going to with the fuel injection. So my car is a 1950 Ford custom two-door. It's right there. And it came actually special ordered with the police package with the Mercury V8 engine in it. So it actually had the 255 cubic inch Mercury, which would have come with this carburetor, which is known as like the teapot style carburetor. And then this intake manifold here, which is just a standard 2-barrel intake. First things first, we'll talk a little bit about our intake manifold. I was thinking to myself, how hard really can it be to mess up an aluminum 2-carburetor intake for a car that maybe is going to make 200 horsepower at the absolute most in its entire life? Okay, so to start things off, we'll talk a little bit about our intake manifold selection for this build. Again, the idea that I had in mind was cheap, reliable, effective, and the car is maybe going to make 200 horsepower at the absolute most in its entire time, at least being this old Flathead V8 that still has all the stock parts in the bottom end. This has the stock camshaft, the stock pistons, the stock rods, and the stock crank. So we're not going to be pushing this thing to any sort of limit, or at least I hope not, but we'll see. So this is an eBay intake manifold. It's a no-name brand for 2 carburetors, and it's a common upgrade that hot rodders would make if they're, say, adding a camshaft or some kind of power adder to their Flathead to get just that little bit of extra fuel and air into the engine to make that bit more power. In our case, we're running actually the forced induction with our turbocharger, so we needed more airflow and more volume of air and fuel to be able to enter this engine at the same time to make more power. We've covered our intake manifold, and the next thing up on the list for any fuel injection system is the throttle body. So with this build, with cost and reliability in mind, I decided to go ahead and try to find a throttle body assembly that included everything I need to make a fuel injection system work, at least from the fuel control side. And you'll see what I mean by that here in just a minute. And what we ultimately ended up with is this little system right here, which happens to be a set of dual throttle bodies from a 2022 Yamaha R7. It's a motorcycle. I'll show you guys that, again, this is a twin throttle body setup. So this whole piece is made as one cast aluminum piece. We do have 2 individual throttle bodies that are both connected on the same shaft. So when I open the throttle blade, you can see that both open at the same time and close at the same time. And that becomes very important because our intake manifold is actually set up for 2 individual carburetors. And in the case of our application, we're going to actually be opening both throttle blades at the same time, feeding both sets of those intake ports on the intake manifold. The other features of our little throttle body assembly here are that it actually includes the fuel rail for the fuel injection system. So unlike many current engines or like V8, say a GM LS or even Ford's engines of like say the mid 2000s, the throttle body was essentially just a carburetor without any fuel. So all it had was an intake blade, or sorry, a throttle blade that would open and let air in, and the injectors are located in a remote location, usually in the ports of the intake manifold. But in the case of this system, the fuel rail and injectors are all built into one unit. So you have each individual injector that fires into each individual throttle body on this system. What's cool about that is that it's an all-in-one system. It's very compact, and the awesome thing about this is that you can actually buy higher volume injectors for this system. Well, they're not actually for this system, but I bought Bosch 80-pound injectors that would normally go in like a GM LS boosted application. And I was able to actually install those Bosch injectors right here into this throttle body system with almost zero modification. I had to remount a little bit on the fuel caps to get the O-rings to seat nice and seal up well. But other than that, they were pretty much a drop-in fit. So right there you can see the tip of the injector that shoots right into the airstream. I've got this, of course, flipped upside down at this point, but that intake tip is right in the best place to get that fuel mixture, or sorry, that atomized fuel along with the air straight into the intake manifold on our Flathead. Okay, so we covered our throttle body and injector setup, and you're probably asking yourself, how the heck are you gonna adapt this thing to your intake manifold that's set up for 2 stock type carburetors? And if you are asking yourself that question, you're asking yourself a great question, but I have just the answer right here on my workbench. And here they are. These adapters were designed by myself and a good friend of mine in computer software. And basically what we did is we took the pattern of our intake manifold here and opened it up just to be one elongated oval. And we did that on both. And then we took the dimensions for the bottom of our throttle body setup and matched that right here. And this still has just a little bit of the filler material left. But anyway, that material will actually come out of that groove. But anyway, what we did is we designed these adapters and printed them on a 3D printer out of a plastic material that is mostly compatible with fuel. I say mostly because there's not really a lot of data on it, but the plastic material that these are made of is called PETG, and it is got a temperature resistance up to about 200 degrees Fahrenheit, maybe about 250, and then it also has some resistance to gasoline. There's been a lot of posts of people on forums and on Facebook who actually soak parts made of this in gasoline, and ultimately it has no effect on the plastic. And of course, in our case, our injector will be spraying fuel down through these adapters and into our aluminum intake manifold. So the actual exposure to gasoline is going to be pretty low. But nonetheless, if we have to set these up on a different material, the beauty of technology and of 3D printing is that we can just find another material. Hopefully they make a filament for it, and we can actually print these out of pretty much anything we want. We're gonna see how well these hold up, and maybe under boost they blow out, who knows, but we're gonna see, and I'll let you guys know. So I've just got our adapters laying on the intake manifold. You can see kind of how they fit there. And then our throttle body system just sits right there. And then I've actually got 2 pieces of cut rubber hose that I put that will join these together with a hose clamp. And of course, these adapters bolt to our intake manifold with a gasket located here between them. But that, you can see how compact this system is with the fuel rail and all the sensors. And I've actually got my fuel line already run here, coming from a regulator that's over there that you can't see. But anyway, this creates a very compact system that sort of has basically about 80% of everything you need for a fuel injection system, all contained into one. Okay, so the next thing up on our list, we've got to get the air from our turbocharger into our dual throttle body setup. And that's where this ugly little piece of fab work comes in, which is what I'm calling an intake elbow for the purposes of this build. But basically this is a TIG welded by me so crudely, so please judge in the comments if you must. But this is a TIG welded aluminum elbow that basically has 2 ports on it that I added for the individual throttle bodies, so you can see those there. And then it also has an extra 3/8 NPT port here, which I'll tell you a little about in just a second. We have a V-band connection here on the end, and then we have a 3rd port right here, or sorry, well, however many number of ports, another extra 3/8 NPT port right here so that we can grab a pressure signal or anything else that we may need for our fuel injection setup. And I'll show you guys real quick. Our elbow fits right there into our turbo and then lands right where we need it to be able to feed the air into our dual throttle body setup. And just like that, the system comes together, and now we've got a direct path for that air from our turbo straight into our throttle bodies. Another key component that most fuel injection systems will use is called an intake air temperature sensor, or an IAT sensor for short. I have a standard 2-wire GM IAT sensor right here. These are about 15 to 20 bucks. They go up if you buy the OEM one. But the good thing is the temperature versus resistance curve for this, which is, long story short, you have to input the curve into the ECU program to be able to tell it when it sees, say, a resistance of 100 ohms on this sensor. That means 70 degrees Fahrenheit. And these are fake numbers. I'm just using them for an example here for this case. But basically, you need this IAT sensor to feed an intake air temperature signal back to the ECU. And so what we did with one of our 3/8 NPT ports is we have a place that we can thread in our IAT sensor right here, right as that air exits the turbo and enters the two throttle bodies. And we can get a good reading of the air temperature that's entering these throttle bodies and going into our engine. Another sensor that's very important for any fuel injection setup is called a coolant temperature sensor, and we have that just right here in place of our standard coolant temperature sending unit. And it's the same type of sensor for this application. It's a similar 2-wire, in this case another GM sensor, again because those temperature versus resistance curves are readily available on the internet. This is a common sensor used in fuel injection and LS swaps in different applications. We're just grabbing the temperature from the passenger side head. Really, there's no logic to that other than why not? It's kind of close to everything on this side of our engine, and our wiring is all kind of be on this side as well. So that pretty much covers it for the fuel injection side of our system specifically. We've covered the intake manifold, how we adapted that intake manifold to a set of dual throttle bodies. Those throttle bodies can contain our throttle position sensor, our idle air control sensor. They have our fuel injectors, our fuel rail, and it's all built into one unit. We then built our custom intake elbow that has a port for our intake air temperature sensor. We have a port for a auxiliary pressure signal, whether that be to a boost controller or back to our ECU, for our manifold air pressure sensor, which is something that I forgot to mention, is for any fuel injection system, especially a boosted application, in which case you actually need a different MAP sensor or manifold air pressure sensor. But anyway, the manifold air pressure sensor is a very important and key component to this whole thing to make this work correctly. And what that is just a sensor that's basically measuring the amount of vacuum or pressure that you have in your intake manifold, again, to make fuel calculations within the ECU program. And the ECU that I decided to use for this project is one that I purchased with my own money, so we'll get that out of the way. But it is called a Speeduino, and this is about a $200 setup, roughly. And it comes almost just like you see, but you basically have to assemble this little enclosure, and there's a computer board inside this enclosure that basically has all the brains of the operation. But anyway, what it has is this little port right here for this little piece of like vacuum line, for example, and that port goes to an onboard manifold air pressure sensor. So we have our MAP sensor on board on the ECU. So all we have to do is run a piece of line from that auxiliary pressure port on our intake elbow and run that straight to our ECU, and we have a reliable manifold air pressure signal without the use of an external sensor. So the opening, the V-banded opening in the back of our intake elbow is actually for a blow-off valve. Because we're running a turbocharger on this engine, you have to have one of these to prevent catastrophic destruction to your engine. So basically what this is a vacuum actuated valve that lets off excess air pressure when the engine is under boost, and then the throttle blades are quickly shut to the closed position. And the reason for that is that you basically, without this, you would get a significant pressure spike on your throttle bodies and on your intake manifold, and you can cause all kinds of damage to your system if you don't have this blow-off valve. So this valve basically goes right in this location on the back of our air intake elbow. There we go. So our blow-off valve goes right here, and what it does when I'm under wide open throttle making 156 horsepower with this whole entire thing, and I let off the throttle because I see the cops on the side of the road, all that extra air that our turbocharger is forcing into our air elbow and into our throttle bodies gets bled off instead of causing that catastrophic damage, whether it be through a pressure spike or whatever may else happen in that scenario. And with that, I think we've covered everything that it takes to make fuel injection work. All I've got to do now is put all these components together like a bunch of Legos, and then the fun part is going to be wiring all of this stuff up, wiring the appropriate sensors to our ECU. We've got a few things that require some 12-volt power, but anyway, that covers the way that we're going to get our fuel and air, our pressurized fuel, and I guess technically our pressurized air into our Flathead V8 under our boosted application. So I actually decided to take it one step further with this build and not just control the fuel with our ECU. I decided I wanted to have full control over my ignition timing, and unlike the original Flathead parts that just had a distributor with a mechanical and vacuum advance, and really the operator has no control over the timing curve other than being able to make some minor adjustments with the location of the distributor for the base timing, and the mechanical advance you can in some applications. I actually don't know about this one, but you can with the mechanical advance change out the spring rate to basically change your mechanical advance curve. But since I'm going full fuel injection with timing control, I needed a way to be able to control my ignition timing individually from any other part of the system. And the way I'm going to accomplish that is with using this setup right here. So as you can see, I've already kind of started doing some wiring on this, but what I have here are 8 individual coil packs, and then 4 in this case because I don't have the others on, but we have 8 coils and 8 plug wires, and these coils will bolt on to our head. So you can see I've got a bracket here and a stud back there. So one set of coils will bolt on the passenger head, and one set of coils will bolt on the driver's side head and give us an individual coil pack for each of our 8 cylinders on our Flathead V8. The cool part about this is that we have just a really much more reliable and powerful spark on each one of our spark plugs. Those LS coils are going to make a better spark than probably most other coils in an application like this. They're very popular to use. They have a very high power and they produce a very good, robust spark, and they're cheap as all crap. So I bought that entire set of coils with the brackets for about $80 on Facebook Marketplace. So with those 8 individual coils on our 8 individual cylinders and the input from our crankshaft position sensor, which if you go back a couple of videos, you can actually see how I integrated a crankshaft position wheel and sensor onto the front of our Flathead Ford crankshaft. If I can, I'll throw a clip in right here. And I've gone ahead and started making a bracket to position our crank sensor right here, somewhere about in this spot. That way it won't interfere with the water pump or the belts. So hopefully you guys saw that clip of how we integrated our crankshaft position sensor and our trigger wheel. But basically that crank sensor will give a feedback signal again to our little ECU here and tell it where the engine is in its rotation, and then be able to actually fire each of those coils at the exact time that I tell them to. And that control is fully custom. I can build timing tables to make whatever timing advance or retard from top dead center that I want. And that is going to be critical in, one, protecting this engine, but also making sure that we get the most performance across our full driving range. So I'm really excited about not just our fuel injection here, but also the ability to have full timing control over this engine. It's gonna be really neat. Okay, so that's pretty much a wrap up for today's video. Again, I just wanted to give you guys a full overview of how we're achieving our electronic fuel injection with timing control on our Flathead V8 engine. My next step is gonna be to wire all this up, and hopefully from there, it's gonna be a matter of just hitting the key, giving this thing some fuel, and watching it breathe to life. So stick around for my next video. Check out my other videos if you haven't already. Drop a like, a comment below would be great, and go ahead and subscribe to the channel if you're not already. This one I have a lot of high hopes for when it all finally comes together, and I think you're gonna wanna see it. So thank you for watching. Have a nice day.